Hello everyone! In this presentation, I'm going to explain my laboratory integration project. I'll be discussing the components of my system, identifying subsystem A and the subsystem B, explaining integration model I used, showing a short demonstration, and then sharing some challenges and real-world application. So first, what is a system integration? When we say system integration, is simply the process of connecting two systems so they can work together. In my project, this means connecting data source to a web application so the information can be displayed. Now let's talk about my system. My system has three main components. First is the data source, which is the students.json file. This stores all student records. Second is the component is the backend application built using Flask. This reads the data from the JSON file. So the third component is the web browser, which displays the data in a table format for the user. Beyond identifying the subsystems, a subsystem is simply a smaller part of a system that performs a specific task. In my project, subsystem A is the data subsystem, which is students.json file. Its role is to store and provide data. Subsystem B is the presentation subsystem, which includes the Flask application and the web page. Its role is to display the data to the user. So I use the data integration model because my system focuses on sharing data between these two subsystems, making the integration simple and efficient. Now I'll demonstrate my student grading system. What you're seeing on the screen right now is my project folder. This contains all the files needed for my laboratory integration activity. I'll first explain each file briefly before running the system. So as you can see, this file right here is called students.json. This file belongs to subsystem A, which is the data subsystem. Inside this file, we can see the student record stored in JSON format. So this is the subsystem A, which each student has fields like ID, name, grades, and status. So this is very important because it acts as the source of data for my system. Any changes made here will automatically affect what is displayed later. Then moving on, the next is my subsystem B, which is file name app.py, which runs the Flask application. So this file belongs to subsystem B, which is the presentation subsystem. As you can see right here, the rule of this file is to read the data from the JSON. So as you can see right here, it will read the file from JSON and send it to the browser. Here Flask acts as a bridge between subsystem A and the user interface. So to run my application, I use the command prompt. So this step is required because Flask is a server application. Unlike regular programs, it does not start automatically when click. So gonna right click and open in terminal. The command prompt allows me to manually start the server so it can listen for requests from the browser. So as I click it, it already directed to the file name. So all I need to do is now I will run the server by typing the command Python app.py. So Python app.py. So once this command runs successfully, Flask starts the server. After running the server, Flask provides a local URL, which is http here, http 127.0.0.1. So this address means the application is running locally on my computer and is ready to be accessed using a browser. So I'm gonna Control C and copy. Now after that, open my browser. So I'm gonna open a browser here, and when I open this URL in the browser, my project will gonna appear. So that then as I enter it, here's my student records are already displayed in the table format. So as you can see, the student grading system displaying all student grades as status from subsystem. So it already successfully displayed. So this means the integration between the two subsystems is working correctly. This completes the demonstration of my integration system. Before I end this presentation, I want to share some key insights from my project. In my student grading system, the integration of the two subsystems highlight a few important points. One challenge is ensuring the data format matches. If the JSON structure change, the Flask application might not treat it correctly, which shows how important it is for subsystems to follow a consistent format. Another point is the structural dependency, which is the subsystem relies on the specific fields from subsystem A. So any challenges in the data require updates to the display logic. And finally, data often needs some processing before it can be displayed properly, which is similar to the ETL processes used in the larger system. So this project also reflects real-world examples. School portals, integrating enrollment databases, HR systems, linking employees' records to payroll, or finance software feeding transaction data into dashboards. And overall, these experiments show the importance of proper integration, clear separation of subsystem, and how data can flow smoothly while each part remains independent and reliable. Thank you.